Hello everyone, I'm Vinay Kumar from Vedya Technologies and I welcome you all to this EC Lab Experiments series. So, in this series, let us demonstrate a few of the experiments, right from the basic logic gates to some of the complex experiments down the line in the series using our Eklavya development board, which is a pocket HDL platform of size about 7 centimeter into 6.3 centimeter, where it has a Govin GW2AR processor, and hence you can all get your hands dirty using Verilog or VSTR language. So in this episode, let us demonstrate the implementation of logic gates starting with the NOT gate using our Ekalavya board, which has go into GW2AR FPGA processor on it. And to code and demonstrate the project, we are going to use GW Govin EDA software, which is supported by Govin FPGA processor. So in this video, we will explore how to design logic gates using Verilog language, how to compile, run, synthesize the design using Govin EDA software, program the design onto the Ekalavya development board, and verify the functionality of the design. So before starting, I just want to flip my camera and show you guys our Ekalavya board itself. So so this is our Ekalavya board. Uh, so here is the Govin processor I was talking about. So the processor is of has a. I'll just state few of the specifications. So it has about 20K LUTs, about 15K flip flops. SRAM is about 40K KB, that is kilobytes. BSRAM is about 828 kilobytes. PSRAM is about 64 megabytes, sorry, megabits. SDR and DDR is of 64 megabits and 128 megabits respectively. It has 4 PLL and 8 IO banks. So these are the brief specifications of the processor which is on board. And apart from it, we have FTDI, where we use a Type C cable to dump the code onto the processor. We also have HDMI cable, a camera module, and this board is capable of interfacing with the Arduino uh, breakout boards. So, like multi shield boards, we can use those boards to leverage their functionality and features onto this board and work our way through it. So, having that said, let us get started. Uh, so, yeah, let's start by launching the tool. Now, let us create a project. Uh, okay, since we're starting with not gate, let's name it not gate. Choose a location. Okay. So make sure you select the proper target device name. So the processor which I showed, which is on the board, is GW2AR. The device is just one, that is GW2AR18. The package is ELQFP 144P. Speed is C8, C8i7, and device can be any, but I'll be choosing as C. C stands for commercial. Finish. So let us create a new file. I'm selecting Verilog file since I'll be writing the code in Verilog. Get.v. Okay, I'll be creating one more file uh, for physical constraint file to give the signals. Yeah, to assign the signals to the pins of the FPGA. So let me quickly write the code. I guess that should do it. Save the file, and yeah, let's assign the pins. There are two pins that I've selected, no, created. That is pin A, that is input. I'll be assigning it to the 69th pin of the FPGA board, and IO LOC, that is output Y, which I'll be assigning it to the 136th pin of the FPGA board, FPGA processor. So since we've written the code, let us compile it. This is the compilation. We'll run all, and when running, it synthesizes and it the place and route operation is done. And after the process is done, we can extract the synthesis report here, the netlist file of the written code, the place and route report here, um, timing analysis, ports and pin. Okay, so yeah, power analysis report. Everything is straightforward. You can get your hands on the report, and to extract the RTL design of the code that you have written, this under the tool, schematic viewer, RTL schematic viewer is the is where you will find your RTL schematics. So we have created, uh, let us program. Okay. So our Equilibria board is programmed. Let me flip to the camera. So this is the Equilibria board, guys. Let me interface this with the Arduino multi-shield board, where I can use the features of it, such as switches, and give inputs to it. So I have interfaced with the Arduino multi-shield board. I hope you guys can see it clearly. Yeah, get the down. I know the board is RA Calavia board, and we have interfaced it with the Arduino multi-shield board. So here, the the input A, I've assigned it to the switch one over here, this, and the D4, the LED which is blinking, is the output pin that I've assigned here. So whenever the input, what not gate chases, whenever the input is 0, we will be getting the output as 1, and whenever the output is input is 1, we'll be getting the output as 0. So here I'm not pressing any key, therefore the input is assumed is 0, therefore the output is 1. Now let me press and make the input as 1, therefore I'm getting the output as 0. So that is the value. We have verified the um, not get functionality here. So I've also showed how to open, open and create and open the project, how to create the files, how to extract the report, and the RTL schematics of it. So in the next video, let us see and demonstrate the rest of the gates, that is basic gates, universal gates, and the exclusive gates. So let us catch in the next video, guys. Thank you.